Risk reduction is the second step on the way to a safe machine. The objective of risk reduction is to achieve an acceptable residual risk. Risk reduction is divided into three phases. In the first phase of risk reduction, the team defines appropriate safety measures based on the three-step method. This method corresponds to the harmonized standard EN ISO 12100 and can be visualized using a decision-making chart. Inherently safe design is the first and most important step in the risk reduction process. That is why you always begin with the definition of constructive measures. These measures have highest priority in regards to risk reduction. Among others, they include geometrical factors like, for example, avoiding sharp edges and corners, as well as ergonomic principles, which reduce the physical exertion needed by the operator. The extent of a possible loss can be reduced by rounding off sharp edges. The physical force for the operation of actuators should also be taken into consideration. If these measures lead to an acceptable residual risk, no further measures are required. As design measures alone can be easily and often consciously avoided by the operators, these measures do not generally result in an acceptable residual risk. Additional technical safety measures are required in this case. The requirements for safety-relevant parts of controllers should be described according to the extent of the risk in the standards EN ISO 13849-1, respectively EN 62061. No further measures are required if these technical safety measures lead to an acceptable residual risk. Remaining residual risks can generally be reduced by user information and operating instructions. Let's take a closer look at the three-step method. The safe design of the machine has the highest priority for risk reduction. In step 1, we attempt to make the design safe. In design-related risk reduction, the focus is on the following points: integrating safety into the machine's design, safe operation and maintenance of the machine through design measures. Information on safety design is available in EN ISO 12100, section 6.2. Here you see the non-safe state of the machine in the example. Ask yourself the following question: what aspects of the design can I change in order to reduce the risks? You can enclose the machine as design measure. The glazed protective door still allows a view of the cutting process and the workpiece. Ask yourself additional questions. Is this machine already safe in this state? Is the residual risk acceptable? In order to be able to answer the question about the safety of the machine, you must assess your safety measures. In the example, you can open the glazed protective door and therefore you can still injure yourself on the rotating cutting disc. Consequently, the current risk is not yet acceptable. The extent of the damage was not reduced, but it was already possible to reduce the probability of its occurrence. If the machine's design were safe, no further measures would be required according to the three-step method. In the example, however, the design still does not provide sufficient safety. As a result, you must take additional technical measures. In the second step, you define the following technical measures. The machine's drive must be shut down when the sliding door is opened. In addition, the machine should be shut down by an emergency stop actuator if an unforeseeable situation occurs. But which measures are available to make our example machine safer? The door is monitored by position switches. With a position switch's appropriate assessment and response, you achieve the machine's standstill when opening the protective doors. When the door is open, the drive must be secured against restarting. The position switches are to be mounted in a tamper-proof manner. An emergency stop actuator supplements the operator panel. The machine can be brought to a standstill by pressing the button on the emergency stop control device, regardless of the position of the protective doors. To be able to assess the current safety of the machine, you must evaluate your safety measures. The risks are to be reduced to an acceptable extent using additional technical protective measures until no further technical measures are required. In the example, the additional technical measures provide sufficient safety to achieve an acceptable residual risk. Therefore, you do not have to take any further measures. If further unacceptable risks were to remain after you had taken the measures, an iterative process would have to be performed until the risks had reached an acceptable level. The user information describes the existing residual risk and the protective measures to be taken. For example, wearing protective clothing, mounting identification labels, or maintaining safety clearances. If the user information succeeds in achieving an acceptable residual risk, no further measures need to be taken. In this case, the three-step method is completed. This figure compares the two types in 4 different risk categories. However, the actually required safety level can only be determined by standard-specific information based on risk graphs. Now, based on the requirements of the standard used, select the appropriate components for your safety function. Siemens offers you numerous components with which you can simply and quickly achieve the status of a safe and productive machine. The inspection of the safety function is prescribed by the standards EN ISO 13849-1 and EN 62061. The safety concept must be assessed and documented by means of the failure probability calculation. But how can you check whether you have achieved the determined safety level through your safety functions? Use the Safety Evaluation Tool, SET for short, from Siemens, which is free of charge. For more information, refer to siemens.com/safety-evaluation-tool. In the third and last phase of the risk reduction, the safety concept should be implemented and put into operation. In the case of our example machine, proceed with the following sequence to do so. Implement design measures. Enclose the cutting machine. Implement technical measures. Select, install, perform wiring, programming or parameterization of components. Commissioning the machine. Commission the components and test the safety functions against the specification. Through the design and technical measures carried out, you have minimized the risk to the extent that no further technical measures are required. The state of the technology currently used ensures legal certainty. User information, warning notices and training courses must point out further residual risks.